Momentum and impulse. A couple ways to derive this. First of all, impulse is actually the letter J, and it's equal to force times time. Force times delta t, but we don't oftentimes write delta with time, but realize anytime there's a change in time, anytime we're talking about time. And turns out that's equal to the change in momentum. And let me show you where that comes from. Let's go back to Newton. And let's go back to his second law. It says that F is equal to m times a, and we know that. Well, what's a equal to? Well, a is equal to delta v over t. So now if I multiply both sides by t, I get ft is equal to m delta v. Force times time will cause a change in momentum. Remember, momentum is a product of mass and velocity. So in other words, it makes sense. If I'm going to change the velocity of something, I have to apply a force, and it takes time to do it. Altogether, that's equal to J for impulse. Now, if I take a look at the units real quick, well, the units on this side would be newtons times seconds. The units on this time would be kilograms times meters over seconds. Those are actually the same thing. If you go back to the fact that a newton is a kilogram times meters divided by seconds squared, if I multiply that times seconds, I get the same thing left. So in other words, if I'm going to change the momentum of any object, I need to apply a force. Now let's look at how we can apply that in problems. So with a car crash, we have a 4,000 Newton force applied to a 3,000 kilogram stationary truck for 2 seconds. What is the change in P? So I'm looking for delta P. Well, delta P is equal to F delta T, or FT. You can write it either way. So it's simply going to be 4,000 newtons times 2 seconds, 8,000 Newton seconds. Now, what is the final speed of the truck? Well, key thing is, remember, the truck started out as being stationary, and we know that delta P is, of course, equal to F delta T, but it's also equal to M delta V. So we know this side already is 8,000 Newton seconds. That's equal to, well, delta V is going to be the mass times the final speed minus the mass times the initial speed. So let's go ahead and break that down. MVF minus MVI. Here's the nice thing is that term's 0, so therefore it becomes a pretty straightforward problem. We get 8,000 Newton seconds equals the mass of the truck is 3,000 kilograms times VF. Divide both sides by 3,000. That's gone. And I get that VF is equal to 8 divided by 3, which would be 2.67. And of course that's speed, so it's meters per second. Okay, let's look at another one. Okay, we have a 2 kilogram block moving at 30 meters per second east. So what I have right now is this. Remember, I never draw velocity vectors or anything like that on it. It's sliding like that. I don't know what caused that. It's already happened, so I'm not really going to fool with that. And then what I'm going to do now is I'm going to apply a 10 Newton force to the east. And what I want to do, I guess we need to know how long we applied that for. Let's apply that for 5 seconds. So what I'm now going to say, same basic statement, Ft is equal to m delta V. Well, the F times T is, but here's the key thing now, is my initial velocity was not 0. So first of all, reason your way through it. Is it going to speed up or slow down? Well, it's going to speed up. So what we need to do is figure that out. So we know that Ft is going to be 10 newtons times 5 seconds. That's going to equal the mass of 2 kilograms times VF minus 2 kilograms times VI, which is 30 meters per second. So let's take a look at this and get numbers. We get 50 Newton seconds here is equal to 2 kilograms times VF minus 60 Newton seconds. Of course, now I move the 60 Newton seconds to the other side by adding 60 to both sides. Let me move that up where you can see it. If I add 60 to both sides, over here I'm going to get 110 Newton seconds is equal to 2 kilograms times VF. So therefore VF is equal to 55 meters per second. And that matches up with the fact that we thought it was going to speed up. So that's a good one. Now let's look at what happens when it causes something to stop. This has never happened to most of you, but it happened to me when I was a kid. 60-kilogram teenager rides into a bush at 10 meters per second. If the teen stops in 0.10 seconds, what is the average force they feel? So I'm gonna hit a bush as I'm out riding. Again, I have a force, I have a time. I'm immediately thinking change in momentum. Ft is equal to m delta v. And the other thing is that look for again those key words like stop. That's going to tell you something. I'm looking for F. So F is equal to m delta v over t. You know all those things, so we just plug and chug. 60 kilograms. Now, VF is going to be final minus initial. 0 minus 10 meters per second divided by the time of 0.10 seconds. So I have 60 times, well, 10 divided by 0.1 is 1. So I feel a force of, make sure I'm doing that right, 60 times 10 is 600 divided by 0.1 is 6,000. Okay, I have kilograms times meters divided by seconds squared. That's a Newton. And it's negative. Why is it negative? Come on, tell me. Think about it. It's negative because it stopped me. It's causing me to decelerate. Remember, Ft is equal to m delta v. Kind of an important equation. It helps you a lot. Remember, it really comes out of F is equal to ma, which might be the single most powerful equation ever invented.